Hey, hello. So, what my project is on? So, project is on data lineage. What a data lineage? Data lineage is nothing but the flow of data across like data sources. In a proper data team, we use Snowflake, we use dbt, we use Arango, we use Tableau dashboard for critical business insights, or lot of tools. So, how those data flows and everything is just a data lineage graph. Now, how can you basically get benefit from this data lineage graph analysis? Is that data lineages are crucial for all the data teams here. So just imagine you can get the info like, hey, this dashboard break, this is critical for our business. Like what are the sources that are affecting this? Can you just quickly find those? So let's think about a team which has a lot of folks. Like they have thousands of folks and they have a lot of team. Even in a like small team, if they have millions of data sources or like data assets there, so how can they find like you can keep it right if you can keep an excel sheet, maintain it, and somewhere it is. But if you source that in a graph database like Arango graph and then just use network, there is a lot of graph analysis tool available. So just run a simple query. Hey, can you tell me the what are the down like upstream asset of those? So we will get those and see, okay, we can basically then find, okay, there this problem is. Now let's say there are some governance issues. Like, hey, I can see that this data has a very sensitive. Can we check like where this data is flowing, like in which team is managing those and everything? Can I go to these insights quickly as soon as possible? So there are a lot of questions that can we also like think about one thing that, hey, there are few assets that are not much getting utilized here and there. Can you reduce those? So what we can basically just tell the graph that, hey, give us the just give us the this least connected graph or the isolated assets that are not getting used at all. Can you list me those? So this type of query graph like can provide you pretty soon. So for example, like this will go through this Gartner's like how can data lineage can be like used for your data management capabilities. Like it's there, so definitely like you can do a lot of thing there. Out of all, you have the proper visibility, you can have proper governance. This is like one of the most important thing for any data teams. And now giving the age of AI, and so having data governance and data thing is most important than ever. Okay. So let's get into the project name Lineage Impact. So basically want to show the lineage graph analysis capabilities here. So how I build the data set first. Let's see. So data set is not very easy to get for data lineage use case. So if you want to create those data, you kind of have to create the synthetic data. So how I created is pretty simple. I just created this my own basically generator. That's I created using Claude. So Claude helped me generate all those. So here what I basically meant, like I will provide this in the GitHub repository definitely. So this has basically a few restrictions that, hey, if you are creating table to table relationship only, you will have like source to target relationships, nothing else. So there are like, if you want to, let's say there are a few jobs to read table, so jobs are basically an airflow job, or so if that converts to some table, so it should be on these relationships. Now for example, in Snowflake you will only have these type of assets. In BigQuery, in ArangoDB, like kind of we will have this type of assets only. But in BI tools you will have these type of assets. So you will I will just create those graphs between those. And for example, Kafka has this topic and schema, storage S3 as bucket. Okay, put those restrictions, made made sure that there are some open nodes, made sure there are some disconnected subgroups. So after making sure all those, so we generated one graph that is on the like output. So you can basically just, if you come here and just run this generator, which will basically call this lineage generator. This is a big a large file, so didn't write it in the notebook, it's in the like .py file. So if you, it will just run that, it will create the in a like gxf format. And what I basically did is that like after generating those, I just uploaded those in the ArangoDB. So basically it's pretty simple. Thanks for making that simple. Actually, I was not expecting that. So definitely after that, graph, CUDA graph, and like analyze the direct graph in the local using the NXRDB adapter. I am using OpenAI LLM here. I was experimenting with cloud, but yeah, I think we found OpenAI much more reliable. So there is now, let, this is basically the dataset generation. If you want to see what the dataset looks like in visual form, this is from the ArangoDB's visualizer. It doesn't, like, it is a bit of subgraph, so it doesn't look exactly like that, but like uh, it's a bit complicated. So I try to create as much complicated graph as possible, and yeah, definitely. So now let's go into the how the code works. This is the asset node. So asset node is the every asset. I'm trying to try to normalize those. And if you see like what is the flow here, right? So the agentic flow is user made a query. Now we will see, hey, do we need to first go into ArangoDB graph, basically Arango query to get, and basically this algorithm needs a proper, like we need to run it on a whole graph. So directly can very simple architecture in the like Arango, so, sorry, using LangGraph. So this is basically the code is mostly on the prompting and everything. Given some examples there how to use those, and based on like on that, let's say there are few graph query prompt how to first create, if we need to query on graph, first create those, create basically those queries and then run on it. After that we'll go to network. So like network access is mandatory, but we just making like we want to make sure, do we really not need to decide if the user really need to query Argo first or not. So this is basically how these are getting decided, and everything is basically on the, so this is the line graph where first we decide if we really need to query Arango, then if not, run the graph wide network sec. So I compile the graph, like line graph itself, decide from user if we need to query Arango or not, run graph. If not, just run the graph wide network X. Otherwise, generate a QL query, execute query, get nodes, then run networks on nodes. So simple this flow is. Now I'm just create a bit of visualizer here using Gradio. So let's, so it you can just run it on the Colab or anything. I'm running on a Colab because in my Mac it don't have the CUDA. So let's run it. And this is basically taken a help from Claude to basically just design so on, and it's come out very beautiful. So I'm setting it inline as false, debug true, share true. So let's see what. So let's open this. Open the video, like we can just directly run on it. Wait, this is it. So added few example queries. Why I added this to so that it will be much faster to show off. So this is, I'm trying to find what are the most important asset that team 5 is using. So let's say this, I am a manager of team 5. I want to check what are the most, like what is the most important assets in my team. So we are querying this, and I added, like I have some observability around what's happening using Langsmith. So I'm using Langsmith here for like having observability of all the queries. For example, see this is and graph query is running, and I can basically see what's happening. So like generate equal query, they have generated equal query that, so this is the output. They're saying that should give me all the like asset, and after that like it also returning me the network X code which we will be basically executing on that. So let's see what's the result been. Hey, so we have very good visualized data here. We can see like these are the important asset of the team 5, have some visibility, like so. But that, let's see if there is something, we got something on visualizer. No, not much, because it didn't have any like extra score that, hey, this is the score that is hard codedly assigned, but like the network X one didn't came, so this visualization didn't happen. So we found like there is 7,076 asset, but out of those this is sorted. So you can basically just take a look and find, okay, this is the one. So also, like, let's say I'm just showing you one more query is want to reduce spending on asset, find me the disconnected asset. Okay, so like it is this find, this is I'm trying to find the orphan nodes, what's happening there. And in the meantime, I will just take a look into the like running Langsmith queries here. For example, see, this is running that. I'm checking what are the like queries are getting executed. So you will see like, okay, this is, so this is, we are getting some query here. This is still getting executed. And if you just come here, it returned zero asset. So there is no disconnected asset here.